So let's look at the next question. Carbonyl chloride COCl2 is manufactured by reacting carbon monoxide with chlorine. So this is the equilibrium reaction that we have. Delta H is negative. Delta H is energy that is released. Energy that is released from the system. Now, because it's released from the system, one way of looking at it is the system loses energy. So this is an exothermic reaction. Whenever you see delta H to be negative, it is always exothermic reaction. Whenever delta H is positive, basically what it means is that the system has gained energy. The net energy is gained. So this would be endothermic reaction. Endothermic reaction. So remember, whenever you see delta H to be negative, whenever you see, actually I've written it here. So whenever you see delta H to be negative, that means that net energy has left the system. And whenever delta H is positive, it means net energy has entered the system. And that's an endothermic reaction. You would have read this in the chemical energetics chapter. I have done a detailed lecture on that. You'll see the link of the lecture in the comment section or in the description box. Do have a look at that. So delta H is negative implies this is an exothermic reaction. Now let's look at the question. The process takes place in a closed system, okay, and equilibrium is reached. The condition for the process is 200 degrees Celsius and 200 kilopascals. Okay, to explain what is meant by a closed system. Now, I have done a detailed analysis. I'll spend some time on it just to give you an idea. So open systems are systems where both matter and energy can be exchanged with the surroundings. So for example, if this is an open system, matter can enter and leave the system, as well as energy can enter and leave the system. So it's an open system. So basically, reaction in an open beaker, boiling water in an open pan. So these are the examples of open system. The second type of systems are closed systems. In closed systems, what can happen is you can't exchange matter. You can't exchange matter. Matter can't be exchanged. Matter can't be exchanged between the system and the surroundings. But energy can be exchanged with the system and the surroundings. So matter cannot enter or leave, but energy can be exchanged. So basically, sealed flask with a reaction, or typically when we say equilibrium or when we say reversible reactions, they always take part in the closed system. There is another system which is known as isolated system. In an isolated system, neither the matter nor energy can be exchanged between the system and the surroundings. So thermos flask, an ideal thermos flask, insulated bomb calorimeter. This calorimeter, in the physics portion, in the heat portion, you will either have read this or you will read in the bomb calorimeter. I'm not going into the detail of this, but this is part of the heat chapter in physics, thermodynamics physics part. And there is another system which is called adiabatic system. Either your teacher would have discussed this in class or you will discuss this in detail in the grade 11. Now here work can be done on the system. So it's a perfect insulated system. You don't need to focus much on adiabatic system. I just wanted to complete the list, so that is why I discussed. But for us, the important thing is that whenever we are discussing equilibrium reactions, reversible reaction, the important condition is that they can only take part in the closed system. Matter can't be exchanged with the surroundings. System and surroundings can't exchange matter. So the first question which was asked is what is meant by a closed system. So closed system I have discussed in detail, but these are the notes which I have prepared. Would be there in the PDF, in PDF form in the description section. The closed system is one in which no matter can enter or leave, although energy, heat can be exchanged with the surroundings. Closed system is one where no substances can enter or leave. So, second question, what does delta H represent? Basically, this is the technical definition is enthalpy. But again, in grade 10, they don't use the word enthalpy. We write it as heat energy only. So basically, delta H is the net energy that system either gains or loses. So here delta H is negative. It's an exothermic reaction. Delta H represents the energy exchange. Okay, and see, I have also mentioned here why does a equilibrium require a closed system? state how the value of delta shows that the forward reaction is exothermic. We have discussed this. And one thing that I wanted to just mention, I won't be discussing this in detail, is why do we require equilibrium to be in a closed system? See, a very simple definition is, look at this reaction. I won't be spending much time. I just wanted to give you an idea. If matter can leave or enter, so for example, if you add CuCl2 or you let Cl2 leave the container, the system, then you will shift the equilibrium as per Lee-Chatelier principle. So that is why equilibrium can only be reached in closed systems. I hope it's making sense. So next question, deduce the value of delta H for the reverse reaction. Again, what you need to remember is that if we reverse this reaction, this will become an endothermic reaction. So basically, what I'm trying to say is that if you have COCl2 gives CO plus Cl2, then this is a reverse reaction and this becomes an endothermic reaction. And hence, the delta H would be positive 105 kilo per mole. Okay, so now we are discussing the effects. Now, see, discussed many times before, exothermic reaction. If the temperature is increased, one thing that I'll advise is you have to carefully see effect of concentration of COCl2. You have to carefully see on which element of the reaction, which compound are they focusing on. So here they are focusing on the product. Remember this. Now let's start. Now if temperature is increased, the system will try to move in a direction where the concentration of COCl2, the concentration of COCl2 decreases. Why? In the forward reaction, anyways, due to exothermic, the temperature is increasing. Now, if you increase the temperature as per Lee-Chatelier principle, the system will shift in a direction where the temperature should decrease. The temperature would decrease in the reverse direction. So the concentration of COCl2 will decrease. Hope this is making sense. Some CO is added. Now, that is what I was saying, that you need to have a closed system. For example, in this case, if you add CO, you are increasing the concentration. Now, as per Lee-Chatelier, if you are increasing the concentration of CO, the system will move in a direction where the concentration of CO should decrease. That can only happen when you move in the forward direction. Consequently, COCl2 will increase. The concentration will. Pressure is increased. As we have discussed before in the previous question also, whenever they are asking you question regarding the pressure, always look at the number of moles. Go on the left side, 2 moles. On the right side, 1 mole. Now, if pressure is increased, the system has to move in a direction where the moles, the system has to move in a direction which opposes this increase of pressure. Which opposes, I'll write it here. If you increase the pressure, system has to move which opposes increase of pressure. How will the increase of pressure be opposed? You will have to decrease the pressure. To decrease the pressure, the number of moles should be more. Number of moles which are made should be less. That can only happen in the forward direction. And COCl2 concentration will increase. So by increasing the pressure, you are actually manufacturing more carbonyl chloride. So the concentration of COCl2 will increase. Hope this is making sense. Now, a catalyst has no effect on the concentration. It just has the effect on the rate of reaction. Always remember this. The equilibrium is reached quickly. That's it. No effect on the concentration of either the products or the reactants. So next question.